first.
Okay.
Okay, so it says that player 1 has 20 home runs, and then there's a postseason. So for every postseason, he's going to make 2. So we don't know what that is. If he plays 5 games, that means he's going to do 10 points or 10 home runs. I don't know baseball. I do know math, but I don't know baseball. If he plays 10 games, then it would be 20. So it just depends on the number of post games, right? So that's why we just put it's basically like saying question mark, right? We don't know how many games he's going to play. Equals, then the other guy, he scored 25, but he only is going to do 1 per game. So what they're asking is, when is it going to be that they actually have the same number of runs? So to put it in like real life, so he's going to do 20, and then we know the answer is 5. So they're saying, when is it going to be that these people have the same amount of home runs? So here's game 1, game 2, game 3, game 4, game 5. The only reason why I know it's 5 is because we already got x equals 5 or p equals 5. I wouldn't know this at this point, but I'm just showing you what it means. So on game 1, he got 22. On game 2, he got 24, 26, 28, 30. Or how it's maybe he gets that in his first time. We don't know, but it's after 5 of these scorings. And then this guy gets it after 5 of his scorings. So this is 20, 22, 24, 26, 28. He scored 30 points after 5. And then this guy scores after 5 as well. And then the question is, when is it that they've scored the same number of hits? So we set up our problem, and we have all of this ready for us. Now I have to bring this P over here, and I have to bring this 20 over here. So this cancels out, and what's left on this side is 25. And then what's left on this side is 20 plus 1p. And we know 1p is the same as just regular old p. So I'm just going to get rid of the 1 because it's the same exact thing. Now I have a problem here. My problem is I have a number on this side, so I have to get rid of it. They're adding 20, so I'm going to subtract 20. Whatever I do to one side, I do to the other. I'm going to bring this p down because that's what's left on this side. And then 25 minus 20 is 5. Does that make better sense now?
Yeah.
Okay. So we have a couple different problems. This is setting a problem up. Then this one has a fraction, right? This was our previous problem. So let's go over how to work with fractions. Oh, wait. Was this the problem? Well, negative 1/2 c minus 5?
Yeah.
Okay. Perfect. So the first thing we have to do is get rid of this thing that's not attached to the c. So they're subtracting 5. I'm going to add 5. Anything I do to one side, I do to the other. This cancels each other out. What I have on this side is negative 1/2 c equals 5.5. That makes sense now, right?
Yeah.
Okay. If you have a fraction that is attached to a letter, you use the reciprocal, which is the denominator becomes the numerator and the numerator becomes the denominator. So we're going to multiply the reciprocal to clear it out, because negative 2 times 1, negative 1 times 2 equals 1, right?
Yeah.
That's why it cancels out, is because then it turns into 1c. And we know as soon as it's a 1c, it's just a plain old c. So we don't have to put the 1 there. So now what's left on this side is c. And we have to convert this because we can't do 5.5 times negative 2 over 1. So we're going to do 5 times 2 is 10 plus 1 is 11 halves times negative 2 over 1. And then we can just cross cancel. It equals negative 11 over 1, which is just negative 11. Does that make better sense now, seeing it all together?
Yeah.
Okay. Then we have 2D plus 9.7. So the reason why this is a different problem is because we have decimals. So we're going to bring this over here. So they're subtracting D. We're going to add D, and it's a 1D, right? What's left on this side is 3D plus 9.7. What's left on this side is negative 17. Now we have to bring this over here. They're adding 9.7, so I'm going to subtract 9.7. What I do to one side, I do to the other. This cancels each other out. What's left on this side is 3D. And then since these are both negative, I add them together. So 17 plus 9.7. 26.7. And we know it's negative because I have a negative and a negative. Now for our final step, we have a 3D. So we have to get our 3 away from our D. They're multiplying, so I divide, and then I do 26.7 divided by 3, which is negative 8.9. Kind of makes sense now?
Yeah, definitely a lot more.
Okay. I'm going to continue on since we finished your homework because there's other stuff coming up. So, distributive property. Did you guys go over that today?
No, I don't think so.
Okay. So, distributive property is when you have something that is touching the parentheses. So what we're going to do for that is whatever is outside of the parentheses has to get multiplied to everything inside of the parentheses. Do you remember doing that a long time ago, like last year?
Yeah.
Okay.
Yeah.
So you're going to do what is 4 times 8? 32. And then you're going to put the subtraction sign. And then what is 4 times C? It's 4C. Does that kind of make sense to you?
So you just did, yeah.
Okay. And then on this side, we have 8C minus 6C. So I'm going to combine like terms, which means I have a positive 8 and a negative 6, and they're both C's. Biggest integer wins the sign. My biggest integer is a positive, and it's 8. So I have a positive and a negative. I subtract these integers. So what's left on this side is a positive C plus 16. Make sense?
Yeah.
Okay. Now, I have a regular old problem with numbers on both sides and letters on both sides. So that's more manageable now. So we're going to bring this over. They're adding 2C. I'm going to subtract 2C. Anything I do to one side, I do to the other. I have a negative and a negative, so I'm going to add these integers together. And then I have my 32 here. So it's going to be 32 minus 6C equals what's left on this side is 16. They're adding 32, so I'm going to subtract 32. Anything I do to one side, I do to the other. What's left on this side is negative 6C. What's left on this side? Biggest integer wins the sign. My answer is going to be negative. I have a negative and a positive, so I'm going to subtract. 32 minus 16 is 16. So on this side, I have a negative 16. Now the thing that I have to do after this is I have to get my negative 6 away from my C. They're multiplying, so I divide, yeah?
Yeah.
Anything I do to one side, I do to the other. What's left on this side is a C, and then what's left on this side, I'm going to simplify this. So the only number that goes into both is a 2. I'm going to divide the numerator and the denominator. I have a negative and a negative, so this becomes a positive because it's division. And then to simplify it, I'm going to do 16 divided by 2 is 8. 6 divided by 2 is 3. So my answer is 8 over 3. It's very tricky. I get it. Watch it every day and it will get less tricky.
I have a question.
Yeah.
So is the left side always going to be with the letter or no?
Well, sometimes you can make it be whatever you want. So I could have brought this over here. I just personally prefer if I'm not gonna go out of my way to bring a letter that's not over on the right side. Like suppose you had 5 equals 5C. I'm not going to bring this over. But if I have a choice, like I have letters on both sides and then I have numbers on both sides, I prefer to have it on the right side. That's just what I like.
Okay.
But like for this, I'm not going to bring it over here. It's already there. I don't have to do much. I'm just going to keep it there and I'm going to say they're multiplying. So I divide anything I do to one side. C equals 1. I just don't prefer that if I have a choice about it. And the choice would be letters on both sides and numbers on both sides. Then you get to choose what you bring over. In fact, your book did it the opposite way. So your book brought this C over here. See how it says 8/3 equals C? You have a choice. You can do whatever way you want. But that's only when there's letters on both sides and numbers on both sides. Or else you're just going to keep it where it is. Totally up to you. All right. What else are they talking about now? Okay. Oh, you're going to love this. Just trying to make sure I get all of them. Okay, let's do another distributive property. All right, so you're going to walk me through what I'm supposed to do. We see it's a distributive property because I have number and it's right next to parentheses, right?
Yeah. So wouldn't you have to do 3 times 2 and then 3 times 4?
Yep. So 3 times 2 is 6G. We can't get rid of the G. And then we put our plus sign and then 3 times 4 is 12 equals 6G plus 9.
So then you would have to do 6. I mean, you have to subtract 6G from 6G, then it would cancel out, and then
Yep. So in this case, we're left with 12 equals 9. That is not true. So it doesn't mean we did the problem wrong. It means no solution. I know, it's kind of crazy, but that is what it is. So here's the thing. If we cancel our variable out, which is our g, this is the answer. You do all the work and then you write no solution and you are correct. That is the answer. The answer is no solution. And so you would go 12 equals 9, no solution, and you would be correct. That is the answer.
We've never seen that before.
I know. Algebra's getting crazy on us. But we just did the same thing as we always did. We distributed this over here. We got rid of everything. When this kind of thing happens, it's a thing. And we now know it's a real thing. And it's a no solution thing. So that's what we're doing today. I will send this to Mom, and I would like you to watch it every day. And yeah, you got to watch the other one too. I'm sorry.